today we'll talk about serverless architecture. As we see nowadays that everyone wants to go serverless. Looks like that's the silver bullet. But is it? So let's do one thing. Let's look into what really a serverless architecture is. And then what are the different things you might want to understand before adopting whether to go for serverless architecture or serverful architecture. Okay. So a little bit of background before we start. In very good olden days, we had, let's say, hardware, and the software was sort of embedded inside it. So you would build a hardware which would also had all the logic built into that one. But then people realized it's very cumbersome to do that way. So what they did is that they basically separated it out, said that there are hardwares, which is their interfaces, and then you can basically program your software on top of it to isolate the behavior. Okay. We went little further. With this, what was happening is that with different hardwares, with their own interfaces, you have to learn everything and learn how to basically program that piece of hardware. So people said that, okay, let's do something little differently. We can have a different kind of hardwares, but we will have a common software layer. Common layer. And then what you can do is that you can write your applications on top of that. Okay. And that's where the OSs evolved. So what happened is that there are hardware and there are OS, and then there are applications on top of that one. Okay. Again, there are like many different kind of OS that started coming into picture. And the applications still need to know that if it has to run in this OS, it has to do certain things in certain way. If it has to run in a different OS, it has to do it in a certain different way. So people put another level of abstraction on it. What we call it like the application, we can call them like app runtime. So a good example could be like Java or Python. So what happens now is that you basically write your application which adheres to the application runtime interfaces, and application runtime interface in turns knows that how to basically adapt itself based on the different OS it is running on. So this is like one of the things that was going on. But at the same time, what happened is that we had this client-server applications coming into picture. And with this client-server applications, what happened is now, if we draw the same layer from the OS level, we have now app runtime. But then you have to do a lot of heavy lifting in terms of writing servers which can support the notion of the server and basically listen to the request and those kind of things. So on top of that, people start putting a server. For example, Tomcat. So Tomcat isolated the application developers one more level, and they started writing their apps or web apps, whatever we can call them, on top of this one. But still, even with this server and app runtime in place, you still have to do a lot of other things before you even start writing your business applications. So to solve these problems further, people came up with application development frameworks, app dev frameworks. Again, another good example is like Spring. So what Spring did is that Spring provided you the capability to build all the infrastructure which is needed for an application to even before you can write your first business logic, and then you just focused on writing your app on top of that one. Okay. Now we are sort of very comfortable with this notion, but now what people are figuring out, or basically they are exploring, is that okay, why even to write an app? There are sort of things that basically can be taken care of. Essentially, if you see that from a business perspective, what I need to do is basically the ability to write that function that serves my business purpose. So why not just provide me a capability to write my functions. And that's where this whole notion of serverless started evolving. So what happens is that this whole thing is basically now managed. This is still a server, some server is still running somewhere, but it is now managed for you. And from your perspective, what you see is basically that you just write a function, and this is basically a serverless. From an end user and application developer perspective, it looks like a serverless application, because the only thing that the app developer is basically concerned with is basically to write that function, also known as FAS, function as a service. It doesn't mean that there is no server, there is still a server. It's just that you are not aware of it, or you don't have to even care about it. You can still tune some of the parameters for that one, but more or less your focus is mostly on writing functions. So, is this a silver bullet? Let's see. So what we'll do is that, again, let's just evaluate it based on the things that help us in the serverless architecture, the things that still we should be aware of if we want to basically build a robust application kind of thing. Okay. So some of the good things about serverless architecture is speed of development. You can just focus on writing your functions. A lot of other things are taken care of for you. Okay, you don't have to. You still have to package and deploy. It's not at the level that what you have to do when you have to write a whole application yourself. And even the deployments are very easy. So the hot deployed deployments are usually also very easy. Hot deployments or redeployments. So these are also very easy. And a little bit talking from my experience with using AWS Lambdas. There are other like Google and the Google Cloud and the Azure, they also provide this kind of notion. And I'm sure some of these things would be valid in some way there. But again, like whatever I am speaking is more from the experience that I got from AWS Lambda. Then the most important thing is it handles scalability transparently. Okay. It handles the scalability transparently. So basically, if the number of invocations on your the number of invocations or the number of requests coming for your functions increases, the AWS or whatever the provider is, it will automatically be able to scale it for you. Only thing you have to worry about is the bill that you might run. Okay. Then let's look into some of the things that you really need to understand and take care of while working with serverless environment. So I would not say negative or positive, but I would say that just like these things are, I just have to look and understand that okay, these are the basically the criteria that you have to weigh upon. Then from that perspective, you actually what happens is that right now with the serverless architecture, still. So for example, if you're in a server mode, you know that you can like build your connections, pools and things like that, which helps in performance. But in the serverless architecture, till these servers or the serverless environment becomes more smart, these are the areas that you need to be careful about, because if you're just like calling to a database, opening and closing the connection might be an overkill at times. Yeah. And in fact, if your traffic suddenly spikes up and you don't have so many sort of connections you have allowed on your databases, it can bring some trouble. Okay, so it's basically the serverless environment need to become more smart. Okay. Then there are things like authentication, authorization, logging, So generally it's a common problem with any distributed environment. The only thing is that in the serverless architecture, there is another concern also. Is usually there is a constraint on the execution time and resource. So in server, when the environment is full, server full, these things you usually can put a layer on top of that and things like that. But here you have to be careful because the time, you have to be careful about your execution time in the sense that there is always a upper cap in sort of execution time. So you might just want to do your business logic as much as possible, and the authentic authorization can happen out of that one, which sometimes is not very easy when you are dealing with like business level authorizations. So these are the things you really want to weigh so that your authentication authorization are not compromised. The logging, again, it's like in any distributed environment, it's a common problem. So you have to use systems where you can like push logs and maybe tag them in some way that you can trace the whole workflow. Okay, so I would not say logging a specific issue with the serverless itself. It's like the way you build any distributed environment, you have to take care of it. But yeah, at the same time, whatever you do, you are basically eating from the execution time and maybe from your execution resources also. Then the other area which need to evolve would be the testing frameworks. So things are evolving a lot in that area, but essentially what you also need is like an environment which can be replicated locally so that you can run test cases around that one. So hopefully with these things you will get a better idea of like what are your levers basically to figure out whether a serverless architecture makes sense for you or doesn't make sense for you. Again, like for anything, I would suggest that don't take it as a silver bullet. See that what your context is in which you want to use certain kind of technologies or frameworks. Serverless, with the serverless thing, there is a limitation in the way the complicated data models you can build in memory. In the server case, for example, sometimes we build a much more complicated data models. There are things that are happening on continuous time basis, which can be achieved in serverless, but not very easy, and especially with the constraint on the resources and the execution time, you have to be very, very careful on that front. But still, I think there are use cases where serverless architecture fits very well. I would put the paradigm in a simple way that, for example, if you have a request, you have a very clear-cut point processing, what I call it. I think, and then you need to scale it arbitrarily as per need. These are the situations where serverless architecture, I think, does make a lot of sense. For example, like in the IoT world, you have data packets coming from your devices, and you don't know, like they might just go, they scale up, they might just scale up pretty fast. And then what here we want to do is just that, take that data packet, do some processing, maybe some transformation, let's say some transformation to make sense of like the values that are coming out of here, and then persist it into some data store. I think these are the use cases where you really want to evaluate serverless architecture, because again, even if your devices go from 1,000 to millions, it's like your environment will be taking care of that one, and you don't have to worry about. If you put this logic into a server kind of environment, then you have to keep monitoring, and then you will have to like build a whole sort of distributed architecture with clustering and all those things, and which can scale up and scale down automatically itself as per the traffic that is coming up. But in serverless, everything taken care for you. You just write your function of this transformation, and as the scaling need arises, it will automatically scale. Okay. So hopefully that gives you an idea of how the serverless architecture operates, how to contrast and compare with the serverful architectures. Hopefully that should help. Okay, thank you very much.